So, let's take a look at how this works. Dog mushing. No, it is not a cruel sport where you...
What?
Never mind. That's a bad joke. That's a mean joke. Okay? Dog mushing is when you like tie a bunch of dogs up to some ropes and they pull a human being through the snow for hours and hours and hours, and they make a bunch of videos about it back in the 90s. Balto, Iron Will.
That's such a good movie.
Balto 2.
Balto.
Yeah. Anyways, the distances and speeds for several competitors at certain times are listed in the table of values that we have right here. So we've got competitor A, right? He's traveled 6 kilometers so far, and he's going 24 kilometers per hour. Competitor B, he's a little further ahead. Sorry, no, he's further behind than everybody, or at least the guy in the first place. He's gone 5 kilometers, and his speed is 32 kilometers per hour, and so on. You can read the rest from there. So we're going to assume that the racers are always going at these speeds, at constant speeds.
That'd be incredible.
Okay? For each of the pairs... For each of the... Yeah, will B win? We're not sure. For each of the pairs below, for first, we're going to compare competitors A and B, and then we'll do A and C, and then C and D. We're going to write a linear system to represent their travel from where they are and on. Okay? We're going to graph the system, and then we're going to figure out how many solutions there are to each system. Okay? So let's look at competitors A and B. Let's write a linear system to describe their motion. So, competitor A, how would we do this? His distance is what so far? 6
kilometers.
Okay. And how is he getting more distance?
By going at a constant speed.
By going at a constant speed, right? He's going to gain 24 kilometers every hour. Okay? To find distance, you go velocity times time, right? So this would be how many kilometers he's gone after so many hours if he goes at a 24 kilometer per hour speed. Okay, competitor B, his distance would be 5 plus 32 kilometers per hour. Who's ahead so far? A is, right? Will B probably catch up?
It took about an hour.
Probably, right? If the race goes on long enough. Maybe he'll just barely win. We'll see. Can you just guess, without graphing it yet, how many intersection points there are? Just looking at the equations?
Yeah.
Yeah.
Okay, how many intersections will there be? 1? Why?
Because 5 and 6, they're not the same number, so they're
So I have different y-intercepts, good observation,
and different slopes.
and the slopes are different. Right? If you think back to the table we had, the only one that said different slopes was the first one, intersecting lines. So right away, you know if the slopes are different, you will only have one intersection, guaranteed. Right?
So if the slopes are the same, it's either parallel or...
Correct.
Yeah.
So verify that for me. Graph it on your calculator, y1 and y2,
Man,
and tell me if they cross only once.
I smell like recycling, man. It's so terrible.
And then tell me where that intersection is. Okay, so let's find this point of intersection. First equation is 6 plus 24t, or x in this case, since we're using our calculator, and the other one was 5 plus 32x. Window settings, x is the amount of time that they race, so 0 hours is obviously the minimum. And let's just go 5 hours to start with. The distance is definitely going to be a 0 for a minimum. But the maximum, well, one guy's at 6 kilometers and the other one's at 5. So let's try 10 for now and see how that looks. Oh, wonderful. Let's try a little higher window. 30 maybe? There we go, that's better. So you can see they cross pretty soon, pretty quickly. Let's find that intersection point. There you go. 0.125 hours. Both A and B will be 9 kilometers along. 0.125. Anyone else? Same thing? So what does that mean? You said 0.125
Hour.
and 9. What does that mean? So in 0.125 hours, competitors A and B will be at the same place, and B will overtake A.
So that's not very long.
It's not very long at all, right? So it's pretty quick. He's in danger. Mush!
Yeah, that's like 15 minutes.
Who came up with that word?
Maybe it's like a different age. Maybe it means something else.
A and C. Let's compare those guys. We already have the model for A. That was 6 plus 24t. Somebody give the model for C.
4 plus 24t.
Good. 4 plus 24t. Okay, someone find the solution for me really quick. Or hold on. Maybe predict how many solutions there will be. Just looking at the equations.
Just one.
Just one?
Wait a second.
Look at the slopes. The slopes are the same.
Man.
Okay, so the slopes are the same. What about the y-intercepts?
Oh, so they're coincident lines.
What about the y-intercepts? Are they different or the same? They're different. So what do you know? They're parallel. And it makes sense, right? You have this guy, he's 6 kilometers along the trail. This guy, he's 4 kilometers. But they're both going the same speed. So they're never going to catch each other. Right?
That'd be a long race.
Graph it just to check. Make sure they are indeed parallel. Okay, so let's make sure these lines are actually parallel. So we had 6 plus 24t and then 4 plus 24t. And notice again, our slopes are the same, our y-intercepts are different, so we should have two parallel lines. And there we go. They are indeed parallel. We could shrink up this window maybe a little bit, maybe just make x go to 1. That would scale things a lot more nicely. There we go. That's a better visual of what's happening. So yes, they are parallel. All right, let's look at C and D. We've already got the model for C. His was 4 plus 24t. And the model for D, what would that be?
The same.
Same. The same. So, how many times do you think these two lines intersect? Infinite?
Why do you got the little d's there?
That means distance.
Oh, okay, never mind.
Okay. How do you graph two lines in the same place and know that they're actually overlapping? You guys know that?
No.
Did I ever show you? Show you a cool trick. So graph both of those lines. 4 plus 24x. And the other one is 4 plus 24x. And obviously they're the same. But sometimes you have two equations that you're not always sure if they're actually coincidental. Right? The equations look different, but realistically, one might be a multiple of the other or a factor of the other. And so they are coincident, but just from the way the numbers are set up in the equation, it's not always clear. So if you're graphing two lines and the one pops up and you're pretty sure you got both of them correct and you can't see the other one, here's a good strategy. You see this line right here, right? If you move your cursor over to that line, see how it's flashing there now, and you hit enter, that will make the second line thick. It'll make it bolded. So when you go to graph these lines, you can see it'll happen pretty fastly. It'll happen fairly quickly. You'll see this first line come up as a skinny line, and then soon after that, you'll see a thick line overlap it. And that tells us that these two lines are coincidental, that the second line is laying over top of the first line perfectly, right? So we graph it, and there we go. It happened pretty quickly, but you could see the first line was graphed, and then the second line was right over top. If I left that alone, right, I just keep hitting enter till it goes back. These other lines are for other things. But if I graph it just like this, you only see the one line, and you're not always sure where the other one is. Like, is it on top of there, or did I mess up my equation, or what? But if you make it thick, like that, then you actually know for sure, okay, they are in the same place, and now you can see that they're both there. So there are infinite solutions in this case. What does that mean in context of erasers?
They're gonna go the same speed.
They're going the same speed, and
They're at the same spot.
they're the same. Yeah, they're side by side, neck and neck. Okay. Mush. Pretty intense race for those guys. Who's gonna win?
Nobody.
No, there will be a winner.
Maybe A.
Who would win?
Oh, this?
A is ahead, but B catches them pretty quick.
Well, it depends how fast or how long the race goes.
I think
Sure.
B is gonna win.
If the race takes longer than this, then B will win. If it's shorter than that, then A will win.
What